All right, just adding this bit that I wasn't ready for last time. So this one here is, we're just going to do this example here. Find the nature of the transformation with the equations here. So I've broken this up. This is straight from the textbook. And we're looking at these examples here in that we've got a transformation matrix. We've got this A matrix. And if I look at those values, I've got -3 and 5, -4 and 5, -4 and 5, 3 and 5. So I'm going to write them in here. So we're going to have -3 and 5, -4 over 5, -4 over 5 as well, and +3 over 5. And if we multiply these out, we will get a determinant of -1. So you can do these quite quickly in the calculator once you work these out. And the determinant is actually a handy way of working out some of these transformations. So the -1 usually denotes a reflection. +1 is a rotation about the origin. So in this, we're looking at, because this has, so the -1 is a hint. It's not all the way, but the big hint here is that we've got this value here is the same as this, but negative. So we get a -a, and then these two terms here are the same. Now, this should bring us to our equation that we get for I'm in reflections. Yeah, this brings up the equation we get for reflection. So cosine 2 alpha, sine 2 alpha, sine 2 alpha, and negative cosine 2 alpha. And this has the determinant of -1. Now, the key thing being here, these two are equal, these are the same, equal but opposite signs. So this is a big thing. We're now looking at a reflection, sorry. So straight off the bat, we're looking at, well, this means that cosine 2 alpha has to equal -3 on 5. And sine 2 alpha, so I'm just going to use my top, so I'm using the top two values because it's cosine and 2 sine. So this equals -4 on 5. Okay, and from this we can go, well, tan 2 alpha is going to equal sine on cosine. So sine 2 alpha on cosine 2 alpha, which means it will equal 4 on 3, because sine 4 on 3, they both have a denominator of 5. So we're unpacking a bit of information here. And the other thing is, because we've got, these are both negative, we have to be in quadrant 3 for this. So that means that if we're looking at 2 alpha here, it has to be bigger than, they've gone negative pi. They've actually done this because it lines up with what we're doing with vectors later. So I'm just going to draw this up because previously we would have used different values for this. So I'm just going to, it's a pretty badly drawn one. This here, we would have usually done +pi and 3 pi on 4. I just wanted to show you these are the same values, just in some of our topics like matrices and vectors, we actually will start looking at a domain of -pi to pi. So that's why we've gone to this instead. Okay, so we've got that there. Realistically, from our trig topic, we should know this domain doesn't help us. We want a domain with just alpha, so we're going to divide everything by 2. So we get -pi on 2 equals alpha equals -pi on 4. So we've got that all set up. Now we just need to solve one of these equations. And realistically, the tangent one, this one here, is our best one, because if you think about the equations we've got, it's got the least amount of square parts in it. So we can take this one, and anytime you can use the tan one, it's better. So we'll paste this over here. Okay, so we've sort of gone down there, and so now we're going to go from this over to here. And from this we get, well, this means that 4 over 3 equals 2m over 1 minus m squared. We multiply by both sides. We cross multiply, so we get 4 minus 4m squared equals 6m. I'm going to add to both sides, I'm going to take 4, and add 4m, so they go to the other side. So 4m squared plus 6m equals -4. What have they done there? -4. Okay, equals 0. From this, if I divide everything by 2, I get 2m squared plus 3m minus 2. All right, now this equals 0. We can either look at splitting the middle term, or you can just use your graphics calculator. This is a polynomial, so put this in your equation mode, or you could use the quadratic formula to find roots. But it's going to give us a value here of 2m minus 1 and m plus 2 equals 0. Therefore, m equals a half or -2. Now, because of we figured out this value before, that realistically our result, our angle, our alpha, has to be within -pi on 2, so -pi on 2 and -pi on 4. So it's going to be within this little bit here. So if we get the highlighter out, it's going to be just in here, which means that our m value has to be less than 0. So we're looking at a negative value here, which means that we're looking at tan alpha equals -2. And that means our transformation is a reflection in the line of y equals -2 on x. All right, good luck, guys.